Hi class, this is Russ. I thought I'd give you a few essential notes that can help you get through uh, the, um, the technical points of Chapter 1. And Chapter 1 deals with a concept in Java called bags. So I thought we'd uh, visit briefly what's meant by this concept. So the abstract data type, ADT bag, so what is it? So a bag is essentially a finite collection of objects in no particular order, and they can contain duplicate items. Okay, so uh, it's kind of like a set, and you can have duplicate items in a set. And so behaviors, in other words, behaviors being methods of the bag class, you can get the number of items in the bag. You can check if the bag is empty, and then of course, you can add and remove objects from the bag. So that seems pretty intuitive. All right, so the class responsibility collaboration card for a bag. Uh, Again, here's the format. So the bag, the responsibilities of the bag would include get the number of items currently in the bag, check to see if the bag is empty, add a given object to the bag, remove an unspecified object from the bag, remove an occurrence of a particular object from the bag if possible. Okay, remove all the objects from the bag, count the number of times a certain object occurs in the bag. So, you know, since we can duplicate objects in the bag, how many duplicates of a given object are in the bag? Test whether the bag contains a particular object. And of course, look at all the objects that are in the bag. In other words, we can list all the objects in the bag. So these are the responsibilities. Um, and so the collaborations are the class of objects that the bag can contain. All right, so those are the collaborations. So a bag holds class instances, and the classes can be like an employee class or um, a student class, a shopping cart class, an automobile class, and so forth. Okay, so that's the CRC card for bag. So it conveys a lot of power. All right, so specifying a bag. So when we specify a bag, we describe its data and specify in detail the methods. Uh, the options we can take when we cannot complete a task. Okay, so if one of the methods can't be done, what can we do? Well, just like in programming 2, if we try to invoke a method and the method doesn't work, we can always opt to do nothing. Um, we can leave the bag unchanged. Okay, so one of the things if a method can't complete its task is we can leave the bag unchanged and let the consumer of the application know that the bag was left unchanged. Um, and essentially nothing was done if we can't complete a method um, for the bag. Um, so in doing this, we have to take note of which methods change the bag and which do not. Okay. So this is a little bit abstract at this point, but we'll be more detailed as we go through this note. Okay, so here's the UML notation, Unified Modeling Language notation for the bag. Here's the method getCurrentSize, which returns an integer. The Boolean is empty. Um, we can add objects of type T to the bag. Okay, and we call this a new entry. And if the addition is successful, we return true. If we can't add, we return false. We can remove an object of type T from the bag. Um, or we can check that. We can remove some arbitrary object of type, some arbitrary object from the bag. That goes to what? Remove an unspecified object from the bag. It's this aspect. Remove an unspecified object. And then we can remove a specified object from the bag, and that returns a Boolean. So if we target an object that's in the bag, we think it's in the bag, and we try to remove it. If it's successful, it returns true. If it's not, it returns false. We can empty out the bag, clear it. If an object is duplicated, an object of type T is duplicated in the bag, we can count the number of times it's duplicated through this get frequency of method of the bag. And we can determine if an object of type T is present in the bag, okay? And we can of course declare an array of bags, okay? Convert the bag to an array, convert the bag to an array. Okay, so these are the UML methods, the methods associated with the bag, um, articulated in using UML notation. Okay, so design decisions for the bag. So how to handle unusual conditions when you're programming with bags. You can assume that unusual conditions won't occur. Um, if a situation is invalid, we could ignore it and hope that the program doesn't crash. We can anticipate what the client will be doing to the program and kind of code around it. Um, if we have an unusual condition that's occurring in the logic of a method, we can kind of quantify it or clarify it in some sort of message and return the message to the user. We can return make the method kind of like a true-false condition. If the method succeeded, return true. If it fails, return false. Or we can use a try-catch block, something we did a lot in programming too. Okay, all right, so let's talk briefly about an interface. Okay, so remember, an interface is something that describes the operations of a bag of objects. Okay, it basically, when you declare an interface, you use the keyword interface. Um, and in this case, we give it the name of the interface, which is called bag interface. And uh, T is the type of object. It's basically a class that you write somewhere else and pass to the interface. Okay, and remember, interfaces just are nothing more than public, or check that, nothing more than method interfaces. They don't contain the code. So for instance, this get current size method, notice it's just the signature of the method and it doesn't contain any code. Um, so when you, yeah, we'll talk more about in just a minute about how you use the interface. When you when your class implements the interface, it's that in that particular class that you'll actually write code for this particular method. Okay, so additional methods that we want to prototype in our interface, the isEmpty, um, add. So in this particular case, the object to be added as a new entry. Okay, so and it's of type T. So return true if the addition is successful, false if not. So here's the prototype for the adding of of a of a class of a particular instantiated object. Remove. So this removes an unspecified entry for the bag. So evidently, it could probably remove the, since nothing's passed, it probably removes the first item from a bag. So we'll discuss more about how to flesh out the remove method again. So removes one unspecified entry from the bag. Oh, actually one unspecified entry. So it could be the first item, the middle item, or the last item. So it's unspecified. Um, what else do we have here? The Here we have a specified entry. So removes one occurrence of a given entry from the bag. So for instance, this object T, if it's in the bag, um, it will remove one of the objects. So if this particular an entry, this particular object is duplicated in the bag, it will remove just one. Okay, and if it removes it successfully, it returns a true. If not, returns a false. Um, okay, and so here's a prototype for what is this? It's the same thing, right? Yeah, public boolean remove T, public boolean remove T and entry. Okay, remove all the entries is the clear. Get frequency counts the number of times an entry appears in the bag. Um, and check to see if a particular instance exists in the bag. And then, um, what is this? Yeah, a newly allocated array of all entries in the bag. Okay, so this is basically uh, uh, essentially converting the bag into an array. Okay. All right, so this is the interface for a class of bags. All right, okay. So using the abstract data type bag. So here in this particular case, we want a class that maintains a shopping cart for an online store, like say Amazon. Okay, so class online shopper, here's your main method, all too familiar, right? And okay, so the online shopper will have an array of items. And so in this particular case, the item, evidently I would gather just looking at these new that the constructor for the item class is what, a string followed by some sort of ID, integer ID, uh, um, product code. So we have a bird feeder, a squirrel guard, bird bath, sunflower seeds. Okay. Uh, and so 1, 2, 3, 4. What there are 4 items in this item array. And what we do is we take this item array, okay, and we de- basically the way we declare a shopping cart is it's essentially a bag interface with items, okay. And here's the declaration of the shopping cart. It's just basically an array of items, and uh, the items are basically placed into this bag interface or this particular bag object. Okay, this bag object. Okay, and then there's the total cost. All right. So what's going on in this for loop? Haven't seen it yet, but it looks like it's an iterator. Uh, it basically adds, it iterates through the array of items, and it takes each of the items in the array and stuffs it into this bag, to the shopping cart bag. Okay, right here, and then it does a get price. Okay, so evidently the item class has a price uh, data associated with it. Okay, so yeah, add selected items to the shopping cart. Okay, and so we have this while loop that oh, in the checkout process, the author has this while loop remove um, items from the bag. So while the shopping cart is not empty, remove the items from the bag. Okay, and then print the total cost. So total cost, which was calculated here in this for loop. Okay, so total cost. Here's the total cost, and I don't see in this code where evidently this remove method must be printing out the name of the product and the cost. So that must be a consequent of the remove. Okay, so we can kind of anticipate with the shopping cart or with the bag interface methods, the remove method does. Okay. All right. So yeah. All right. So this is where I'll stop for now, and then this is a bit sketchy from the author. So probably it'd be a good idea if I were to present an example, and I'll do that in the next video sequence. So if you have any questions about this particular discussion, feel free to post in the Module 1 discussion forum. And I hope everything's going well with you guys. So we'll talk to you shortly.